let's start the stream.
Mm-hmm.
Okay, it is okay. Let's start. I opened it in language because the other colleagues can check the YouTube stream after the meeting too. Hát szeretettel
There are some technical errors there.
Yes, my word was te is így utólag hallottad? Oh. Okay, there was some technical issues, but yes, we can open it. Szeretettel köszöntök mindenkit a Magyar Meteorológiai Társaság Szegedi Területi Csoportjának mai előadóülésén. Hát ezúttal online formában tartunk meg. Mai délután folyamán egy előadást hallhatunk, frissen végzett doktorunk Yuchen Guo előadásában. Yuchen város klimatológiai, azon belül városi hősziget, illetve gépi tanulás témában fogja bemutatni legfrissebb kutatási eredményeit, és utána pedig hát a megszokott módon az előadás után lehetőség lesz kérdések feltevésére, illetve hozzászólásra. Aki esetleg a YouTube-on követi, ott írásban az oldalsó chat falon lehet feltenni kérdéseket. Hát nem is szaporítanám tovább a szót. Yuchen, I would now like to invite you to present the results of his recent research. The title of the presentation is Machine Learning and Shape-Based Analysis of the Temporal Dynamics of Urban Thermal Environmental Drivers. And the co-authors are Ungár János, Molnár Gergely and Kál Tamás. Yuchen, the floor is yours.
Okay.
You can start it.
Okay, so thanks so much, and hello everyone. Good afternoon, and very happy to see you again here, and very thanks so much for organizing this online meeting, and have a chance to share our recent work. So this work is about the urban microclimate. So here we can start it. In this presentation, there will contain these 5 parts. So let's start from the first one. It's about the influence factor of urban microclimate. Urban climate study have identified various influence factor on urban thermal environment, and generally, this factor can be classified into 2 groups, like 2D factor and 3D factor. They have different physical process to influence, to affect the urban climate. For example, the 2D factor, usually they are related to the land use and the land cover information, like the vegetation or the impervious surface. They have different cooling and heating effect. And for the 3D factor, they can shape the vertical structure and the urban spatial morphology. For example, like the scale factor, building height or tree height or some other factor, they can affect the urban climate by providing the shading effect to affect the surface energy balance. But it's not easy to analyze the connection between this environment factor, environment variable, and the urban thermal environment because they are not so simple, they are very complex. But fortunately, now with the development of the interpretable machine learning method, we can do this analysis a little bit easy. For example, we can use this spectral dependence plot to analyze the non-linear relationship between the environmental factor and the urban climate. For example, in this research, they use this PDP analysis to find out how this environment factor influence the temperatures. They are not the linear relationship. You can see this trending point. And use this method, you can easily find out this trending point. And also use other interpretable machine learning factor. You can also analyze the interaction between the different environment factors. For example, in this research, they analyze the NDVI and the NDVI factors, how these two factors impact the urban climate. It's really good development, but there's still some research gap, which is there's not enough research on how this environmental factor impacted the how this environment factor factors impact changed with time, which means the temporal analysis is not insufficient. It's not enough here. There's some reason for the measurement-based research. Usually, we don't have enough measurement station, and usually this kind of measurement only focus on summer or daytime condition. For example, in this research, they try to measure the air temperature in this area, but they have only 4 stations. But they select more than 20 measurement points, so they have to move this equipment to another one every 20 minutes. So they have not enough equipment. Therefore, they can only focus on short period, and they cannot do this work at night. So their work only focus on daytime and summer. And another reason is most of the urban climate research using the remote sensing data, because remote sensing data is more accessible and so is more widely used in this research. For example, in this review paper, they found that there are more than 14% research using remote sensing data, but only 20% research using the measurement-based data. So, but the problem is the remote sensing data usually have low temporal resolution. So if we use more remote sensing data, we cannot have good understand about the temporal variation of urban climate. So to solve this problem, this research tried to use the interpretable machine learning method to quantify the impact of the influencing factor across the temporal dimensions. To achieve this, we need to get the air temperature data in microclimate, micro scale with high frequency measurement. And we need to introduce the temporal factor to construct machine learning models. For example, like in these figures I showed you before, so this is the interaction between NDVI and NDVI. But if we use some interpretable factor, we can analyze how the impact of NDVI change with time. If we have enough measurement data, we can do this analysis. So using this interpretable machine learning, we can do this. We can quantify the interaction between the temporal factor and other environmental variables. we can analyze how this environment influence of the environmental variable changes with time. So this is the main research aim of our study. So for this research aim, first we need to measure the air temperature data in micro scale. We choose the Zhengzhou city as the research area, and we select one neighborhood scale block like this. In this area, there are two university campus, this one, and this one is a residential area. So in this area, we select the 18 observation points to measure the temperature. And this measurement point can be classified into 4 classifications. They are vegetation type, building and vegetation mixed type, and open area. And here we use the open area as the reference station. By this way, we can calculate the temperature difference between the open area set and other sets. We can calculate the temperature difference to analyze how this temperature change with the location field. And in this study, we use iButton date logs to measure the temperature. And we also measure temperature over 4 seasons. And every season, we measure temperature about 1 week for this continuous measurement. And then with this data, we can construct these machine learning models. And the temperature difference is a function of the 2D factor, 3D factor, and the temporal factors. For the 2D factor, we use the NDVI and the impervious surface index IPS. And for the 3D factor, we use the scale factor and the scale factor from building. And the total amount of solar radiation received is the observation point over 1 day. And this solar radiation is calculated based on the DSM data. So this is also one type of 3D factors, which can reflect the urban morphology condition. And for the temporal factor, we use the measurement time, which is minutes of a day. And after the machine learning model training, we can use the interpretable machine learning method to do some detailed analysis. And the first step, we run this machine learning model. And we select the 3 machine learning methods, which is random forest, XGBoost, and CatBoost. We compared them, and we select the best one for the next step. Next step is the interpretable analysis. We use the SHAP method, which can calculate the Shapley value to quantify the influence of the predictor on the model. So this is our workflow. And so after the model training, after this research workflow design, we start some analysis. First one is the temperature difference analysis. Here we compare the temperature difference between the open area and other land cover types. From here, we can see the delta T variation over 1 day. And we can see the significant general variation of delta T over all season. So, which means the daily variation of the thermal environment is not simple, it's very complex. It changes across the day. So we need not only the daytime analysis, we also need the nighttime analysis, because they maybe can change in different time and different season. So first, we can focus on the vegetation area. So in this area, we can see the consistent cooling effect throughout the day in all season, which means there is almost no negative value of delta T. Means the vegetation area, it's always cooler than the open area. But for the building area, it tends to be warmer at night. We can see here, the value here, there's some negative value, which means the building area is warmer than open area at night. But for the building and vegetation mixed area, these have the different thermal behaviors. It's it's a little bit intermittent. So it's not so high, it's not so low, it's in the middle. But we can also see the largest daytime 30 value here in summer. So the reason would be the combination of the cooling effect from both vegetation and building. Because during the daytime, the vegetation can provide the cooling effect. The building can also provide the cooling effect. In this building and vegetation area, they have these two cooling effects. So this kind of combination can enhance this cooling effect for this area. So after this comparison, we can do some machine learning to find out why they have different thermal environments. So first, we train the model, train the 3 machine learning model and compare their performance. Based on this result, we can see the catapults can provide better performance with the lowest RMSE and the highest R square value. So we select the catapults as the funnel model for the shape-based interpretable analysis. And during the model training process, we can calculate the importance of all predicted variables. Here we can see this importance results. During daytime, we can this result we can see the 3D urban morphology like schedule factor and the temporal factor MOD have the most important have the highest importance value here. But at night, the importance of 2D factor like the NVR and the imperfect surface increase. And we can also see the solar radiation contributes significantly. Not only in daytime, at nighttime, they also have very high value, high importance value. So which means this, which means the urban 3D structure have very important roles in the urban microclimate construction, because they can change the energy balance in this microclimate. And this result can get the conclusion that it's valuable to analyze the temporal variation of the drivers' influence, because they have different daytime and nighttime influence. So it's very important to get more details about how their influence change with time, change in during day and during night. So next step, we can show the most important results of our study, which is the shape-based analysis. Here, we can see the result of the daytime. We calculated the shape value of every environmental factors. So if the shape value is higher than 0, which means this variable can increase the dirty value. So which means this variable can give the cooling effect. But if the shape value is lower than 0, which means this variable can give heating effect. Here is the result of the daytime. So firstly, we can see the overall daytime variation here. So during the daytime, the shape value change a lot. We can see the clear hourly change in the environmental impact on air temperature here. And we can see the important driver in daytime. They are solar radiation and the scale factor and the imperfect surface. they have very clear temporal response. And we can also find the seasonal change in shape value responses. For example, like the solar radiation. In spring and summer, autumn, they have different results. Like in spring, if the solar radiation is high, the shape value is high and is higher than 0. But in summer, at the beginning of the morning, if the shape value, if the solar radiation is high, the shape value is high. But in the middle of the day, if shape value is high, if solar radiation is high, the shape value is low. So they are opposite. They have different. Effects. So this result shows that if we focus only in summer, it's not enough. We also need to focus on other seasons. And we can also check every single environmental factors. So in every factors, they have high and low value of this variable. And this high or low variable value can show constructing warming or cooling effect, like this schedule factor. The high schedule factor have the heating effect in the middle of the day, but the low schedule factor has the cooling effect. So they are very clear, this trend or this pattern. So this is the main result of our study here. And next one is the result at night. So we can see this shape pattern is very different from the daytime. At night, we can see the environmental influence remain consistent throughout the night across all seasons. So this shape value keep stable across the all night. And we also selected the first 3 important variables, just schedule factor, impact, and import surface and NVI. So these 3 are the most 3 important factors here. And we can also see some seasonal changes in the shape response at night. For example, in the winter. Like winter's schedule factor is different from other season. So the reason could be in winter there's some heating. In the city we have the heating system, and the heating system can change the urban climate environment. So they have different shape value. So this also highlights that if we focus only on summer, only on one season, is not enough. And we can also see this opposite thermal effects. And we can see the more observable and clear separation between the shape value of the high or low value. So we can see it's more clear compared with the daytime. For example, in the NVI, the high NVI have high shape value, the low NVI have low shape value. So it's very clear. And based on this result, we can see that the influence of this environmental variable, they can change over hours. So in the one day they have different influence. Okay, the last one is the conclusion. Based on the high frequency microclimate monitoring and the interpretable machine learning, we analyze the difference in the thermal environment across the local climate type in neighborhood scale. And we use the machine learning to review the diagonal shapes of the influence of the 2D and 3D variable on the thermal environment. So we can see they have different daytime and nighttime impact. And we use the interpretable machine learning to quantify how this environmental impact changes with time. So this study, we try to provide a new method to for using interpretable machine learning to capture and analyze the temporal dynamics in urban climate research. And here is some reference of the study and also acknowledgement for all my colleagues in Hungary and in China, and also acknowledgement for the ECOT scholarship. Okay, that's all. Thank you so much.
Thank you.
If you have any questions.
Yes, thank you very much for your interesting presentation. If anyone has questions or comments, please feel free to ask. Illetve megnézem, aki YouTube-on követi esetleg az előadást, ott írásban is lehet feltenni kérdést itt oldalt a chat falon. Yuchen, I have just one question. The not so important, but the first chart showing the temperature differences, so the measurement data. Why do we see this very interesting daytime pattern? So there is a large peak in the morning, maybe around 9 or 10 o'clock, and after that there is a decrease, and after that there is another peak, a smaller peak in the afternoon hours. Still, yes, so two peaks. A big peak, and after that a smaller peak, and around 12 o'clock there is a decrease in the shape. So what is the reason for this interesting pattern?
Oh, I think the reason is the pitching at in the daytime. Okay, let me think. So we can see the first peak is around maybe 10 o'clock here.
Yes.
Yeah, and for every season and every landcover type, they have the same peak or similar peak around 10 o'clock. I think for this one, the reason is the direction of the sunshine. My research is focused on the small scale, block scale. So in that scale, they have the similar special morphology condition. So this condition can affect the solar radiation and the direction of the solar radiation. So during the daytime, the temperature or the temperature difference can change with this incoming solar radiation. So it's why firstly they have the similar peak at the same time. Maybe around this time they have the strongest solar radiation here. And so your question is why there are two peaks, right?
Yes. And the decrease around 12 o'clock. And the
yes,
afternoon peak is usually smaller than the morning peak. So
yeah, but you should know this result is not about the temperature. It's about the temperature difference. So you can imagine that in the morning, like before the 12 o'clock, this is the heating process. So in this process, there is a peak. The peak means at this moment, the temperature difference is the highest, right?
Yes.
So after that, these two temperatures are closer. So they are. So in the middle of the day, they are closer. But after that, after the 12 o'clock, here the temperature difference increase because this is the cooling effect. During the cooling effect, the temperature difference changed. The temperature difference increased again, but this increase is not so big compared with the heating process.
Mhm.
So the first peak is in the heating process. And here there is a low value. This is in the middle of night, middle of day, because they are closer. So they are reaching their peak, their temperature peak. So their temperature difference is small. But after that, after this peak, so the temperature difference increase again in this cooling process.
Okay.
So this is my answer.
Okay. Thank you.
Mhm.
And just one remark to this chart. For me, it is a bit confusing that the cooling
Mhm.
effect is indicated by positive delta values, while the heating effect is indicated by negative delta T values. As far as I know, in the literature, it is often the opposite, so the other way around. So the cooling effect is negative and the heating effect is positive, as I know. But it is only a formal issue. So for
You
me,
mean
to understand this chart is difficult.
you mean this one? You mean the heating?
So only just so the cooling effect should be negative delta
Negative?
T, and the positive and the heating effect should be positive delta T, I think. So
But
maybe the other colleagues
yeah, but
are more
we should know
familiar.
this 30 have some meaning. You know, this 30 means the temperature difference between the open area and and other area. So open area is some area like the square. Usually during daytime, like here at this period, during daytime the square area can get more solar radiation and temperature is higher. So I think it's okay. I mean, because this area is hotter than other area the whole daytime.
Okay.
But
Gergely?
yeah, but maybe we can discuss later if you can give
Okay.
me more information.
Yeah, so I think here the illustration is okay, because here we compare the open areas with the other categories. So if the delta T value is positive, it means that the open area is hotter than the other categories. So if we think it from the side of vegetation, it is cooling in the vegetated land use land covers, but this is a positive delta T from the perspective of open areas. So here, what would be important to highlight and emphasize that the cooling the cooling represents the negative delta T from the perspective of vegetation, but a positive delta T from the perspective of open areas. So this is just...
It depends on the perspective. So from what perspective, yeah, we are...
Yes, exactly. So it would be important to better emphasize this, but I think it's generally acceptable way of interpretation.
Okay. Thank you. Any other questions or comments?
Okay, do you have any question?
I checked the YouTube stream. No No questions. I ask again, any other questions or remarks to you, Chen? No. Okay. If not, I would like to thank Yu Chen for his presentation. And I think I can close this short meeting. Szeretném megköszönni mindenkinek a részvételt és a figyelmet a mai előadóülésünkén. Yu Chen, thank you again for your participation and for the presentation. És további szép napot kívánok mindenkinek. You can have a nice day or night in China.